Hello, welcome to another session of Electronic Assisted Astronomy with an 8-inch Schmidt-Cassegrain telescope. My name's Pete. We're observing from the Isle of Wight. It's late November. The temperature outside, I believe, is 4.7 degrees, and the sensor temperature of my Altair Astro 294C is 7.1 degrees. So this is the first night since last winter that the temperature has been below 10 degrees for the sensor temperature. We're using the latest version of SharpCap 4.1. We aligned using the new SharpCap Solve plate solver, which was very quick. Yeah, so that's brilliant. What else have we got today? So we're looking at currently M92 in Hercules, which is setting down into the kind of, I don't know, northwestern sky, I suppose. It's how high is it currently? 32 degrees high. I just checked. I got my observation database up from AstroPlanner, and the last time I managed to observe was the 14th of October for all different combinations, mainly weather. Obviously, life gets in the way as well of observing, as you well know. But anyway, so tonight I've looked at M29. I've also looked at the Comet. I used M29 just to focus on because I finished my alignment. I was using, as I said, the SharpCap plate solving, and that worked perfectly. So I use that as default now, but I still keep AsTap and All Sky plate solver installed, just in case, and also because AsTap's a very good application in its own right. Yeah, then I switched over to look at 12P Pons-Brooks, which is a comet heading in our direction. It's coming in from a very high inclination, and so it's going to go straight through the plane of our solar system between the orbits of Earth and Venus, and later next year, well, early next year, but there we go. So M92, we've been on this for 6 minutes 56 seconds. Like I said, we're using the latest version of SharpCap, using the latest version of AstroPlanner, and this is slightly different. We're using Starry Night Pro 8 as our planetarium program. Now, I purchased Starry Night Pro 8 several years ago. I don't think it's been updated since 2020, but one thing that made it kind of fade into the background for me was that it doesn't support any external access, so I can't, as in Stellarium and the Sky and CDC, C2A, even AstroPlanner. I can't control it. I can't say, where to go to in the sky and set the field of view and things like that. And I confirmed that with a ticket to, is it Simulation Curriculum to make it? Yeah. And they said, no, doesn't do it. But they do have an SDK. Now, it's a very old SDK. It was written many years ago, but it's what they use to create their ASCOM telescope and ASCOM focuser plugins. So I downloaded the SDK and built it. There was a little bit of a type def problem, but that's fine. It's easily solved. Built it, and then Starry Night Pro didn't recognize it. Asked them about it, and they said, well, it's really old. Maybe it doesn't work. But no one can look at it. So okay, so almost gave up, and then I realised that all their other plugins, the two which I mentioned, had a kind of suffix of _Win32. So as soon as I added that on it, it worked fine. So I stripped out the example focuser and created a little remote plugin. So now it works in exactly the same way as Stellarium. Sorry, it's not as powerful as the Stellarium's remote plugin, but it does allow me to do things. So, for example, I can change the zoom out to I call it constellation view, naked view, come out a bit further, hopefully. Will that do it? Oh no, it's still thinking about it. There you go. So there's the naked eye view. So that's where we're looking right now. We're looking down into that northwestern horizon just above the trees here right now, and just as before, I can now sync. So where I'm selecting N92, I've got my imager field of view set. So if I sync, I can go back in. So now I can actually use it which is great. It does have some advantages. In fact, why don't we? We've kind of done enough on M92. Let's just log M92.
Observation M92 created.
And what we do instead, we'll go to the Comet 12P Pons-Brooks. I can't remember if on my targets I'm going to slew. Let's have a look at my config. Yes, I am going to slew. So if I target 12P and slew.
Telescope slewing 11 degrees.
Not very far because it's passing from the constellation of Hercules into Lyra. Now there's one thing I noticed that when I got...
Slewing completed.
Right. There's one thing I noticed, and I've told you this before. AstroPlanner is very good. It will put comets or asteroids within the field of view, but not very precisely. In fact, if I sync my planetarium, you will see that Starry Night, just like Stellarium and the Sky, though I find Sky the most accurate. And when I say that, I mean Stellarium and Starry Night Pro are very close. But when I compare it to kind of the gold standard of JPL horizons, I find that the Sky gives the better coordinates. But as you see here, Starry Night is saying that actually the comet is not where I think it is. It's further up here. So what we can just do, if I just right, oops, he says, if I right mouse, and I'm just going to slew to the comet using Starry Night Pro. In fact, if I just center that, there we go, so it's very close now, and if I just center that, so now hopefully the comet is directly in here, and then what I'm going to do is I will do an 8-second exposure. Let's capture. Starry Night Pro, as I said, has been updated since 2020, so I'm not going to recommend that you rush out and buy it. Oh, there we go, there's the comet. Right there. It's a lot brighter than the last time I looked in September. You can see the kind of central part of the comet and then this kind of diffuse gas all the way around it. Let's do it again. What are we on? Oh, we're on, let's make it 2. Colour seems wrong. Better. Let's stretch it a little bit more. There seems to be a distinct kind of triangle. In fact, let's zoom in. Do you see there's this brightening here? This kind of fan shape coming up. Now the problem is comets move, so this is going to smear the image because I tried to get the comet tracking working and I couldn't get it working. And being this is my first observation for over a month, observation session, sorry, for over a month, I thought I would not bother reading the manual. So we'll just do this as a thing. But there's definitely a brightening this way on this particular comet. And now this is one of the reasons I use Starry Night Pro, because it has got some features that other programs don't. So for example, this is Pons-Brooks as we see it in the night sky, but I can go to Pons-Brooks and take a look at it. So what I'm going to do actually is I'm going to go out into the solar system. And so this is my solar system view. So this line coming down here is the orbit of Pons-Brooks. And as you see, it comes from the outer solar system. I think it's every 70 odd years is the orbit. And if I zoom in, you'll see that it's going to come in between the orbits of the Earth and Venus. This is now. And if I hold down the Shift key, the cursor should change, and then I can just spin it round. And now you see how the comet is going to come straight down through between Earth and Venus, and then back out to the solar system. So it is kind of yeah, coming straight down through the middle of our solar system. And what we can do obviously is if I set up a custom time period of 6 hours, because this seemed to work well. If I press play, and now the planets start to move in their orbits, we're up to, what's that, the 30th, the 2nd of January, These are the other comets coming in. There's Pan-STARRS and coming up that way. And here comes Pons-Brooks, and it really speeds up as it comes down towards the sun. It goes straight through the middle of our solar system. We're over here. And back out into the depths of space, past the orbit of Neptune. So that's cool with Starry Night. But we can also, if I put that back to the original favourite I had, I can also go up and select it. Let's select Pons-Brooks. And what I'm going to do now is I'm actually going to go there. And so it has some models built in. This is not obviously a real model of Pons-Brooks, but it has a model built in. And the great thing is that now we can fly with Pons-Brooks through it. So what we can do is we just do it again. We have our 6 hours selected and we'll press play. And now we can still move it around as we're doing it. And here we go. Oh, that was my phone. Sorry about that. Here we are flying through the solar system as we plummet downwards straight through the plane. There's our planet disappearing that way. Venus is coming towards us, but we're going to come straight between the two orbits. And as we go through and out, as we follow this path out into the solar system, to return in 70 odd years time. So catch it while you can. That I think is one of the nice features of Starry Night, which others don't do. There are other programs that do it, by the way, but not the ones I use, like Stellarium or the Skies. So that's quite nice. It's quite, I find it quite interesting while I'm observing it. I'm smearing that image now, but while I'm observing it, just to explore what's going on. In fact, let's find out what the actual orbit is. It was other data. It's on an orbit of about 17 astronomical units, and its year is 71.3 years. So it won't be back for 71 years. And we can just go back to our view, back to home, and then I'll sync my planetarium back to where we were. And we know now that we've got a center on where it thinks it is. And there you go. So good use of Starry Night Pro. It's an interesting little object, isn't it? And it's going to get brighter and brighter, and it has this tendency apparently to erupt. It has obviously ice volcanoes, and it erupts to make it even brighter. And apparently it did this in its last, is it apparition? Hold on, we've got some red. Have we got some brightness issue? Yeah, so something's just drifted across in front of our scope, which is always good to know. But we are quite low, like I said. So if we go to the northern sky, we're up here in the northern sky. That's where the weather's coming from, as in that's where the wind's coming from, but there shouldn't be much clouds tonight. It's starting to recover, as you see, on the brightness down here. When I first click on it, it doesn't accept the first click. So if I click away and drag, no, I've got to click again. It's got some very un-Windowsy kind of thing as well. It doesn't kind of honour the Windows managers, the way Windows managers work. But it does support me, allowing me to pin it on top, which is unlike CDC, which doesn't. But there is a way around that actually now, actually built into Power Toys, where I can reparent Cardus du Ciel. I'm butchering French, sorry, because it's not Cardus du Ciel, Sky Chart in English, but I call it CDC. So CDC, the way it's written, it doesn't allow me to pin it, but I can reparent the window, or at least the main visual area with the toolbars in it, and I can use that as well. Obviously, the other thing is just to run it on the laptop because it's very lightweight. So there we go. That's one of the features of Starry Night. That's that. We've done 3 minutes 36 frames. We've projected 15 because we're currently apparently got something drifting across in front of us. I've already logged it tonight, so maybe what I'll do is I'll just log plus it which just adds.
Observation 12p / Pons-Brooks appended.
Excellent. So I think that's going to give me, yeah, there we go. So we've got 4 different observations of it tonight with some information on them. That's perfect. Where should we go? M13 is far too low. M92. While we're in the area, let's. Oh, NGC 188. You just sync the planet. Oh, I didn't want to sync with that. So that's a little cluster. Where are we? Oh, we're to the north. So let's go NGC 188. So if I check, we're going to slew. We are. So if we target that, and yes, we're going to slew.
Telescope slewing 52 degrees.
Here it comes. NGC 188 is Caldwell 1, which is an open cluster. So let's go there. Sorry, I pointed at Steve Amira's book. It's just over here.
Slewing completed.
There we go. So the moon tonight, yeah, is 92%, and it's 40 degrees high right now. So it's not too bad. Let's come up. Let's change our rate to 8. I always use SharpCap. SharpCap's control. I always find, I don't know why. I mean, there's loads of ways of controlling it. Even Starry Night, let me show you, it's got its. Whoops, can't say. It's got its own little telescope control. But I always end up using Starry Night. And if I could do that, if I come this way, then because of the backlash in my scope, it's not too bad, but it will start drifting slowly, so I always pull it back slightly. Actually, the backlash is not too bad. I think my clutches are getting worn over the years, and if I tighten them up slightly more than I maybe should, it doesn't have much. So there we go. So that's NGC 188. I'm going to capture at 4 seconds, I think. I didn't. Oh, I did clear it. Oh, wow. Look at those stars. Let's adjust the colour. Well, it's quite a large cluster here, isn't it? So let's just try, if I use DSA, obviously we're nowhere near it, I'll show you, I'm attempt to. Let's see how fast SharpSolve will plate solve this particular. It's done it. It's pretty fast. And it's NGC 188, so we have got the right cluster. I'll tell you what we could do. We could go into SharpCap settings and go to plate solve. Should we change it to use ASTAP? It's doing a bit of a dither, so let's be fair about this. I'm thinking I'm dithering every I'm dithering every 3 frames. Let me do a nearby. Yeah, that's pretty fast as well. So, but if it's built in, it's built in, isn't it? Which is the great thing about it. Let's go back to the inbuilt. You can download, so this is only using the default 0.5 degree smallest field of view, and obviously my telescope's smallest, the height is just over 0.5 degrees. so I didn't bother downloading the index. There's an index that gives you the ability to plate solve with fields of view at 1/4 of a degree, or the smallest part of a 1/4 of a degree. So where were we? We're in plate solving, and we're using that now. Yeah, we're fine. Let's do a nearby again. Yeah, it is slightly faster, but I don't know what that is. But yes, very good. I also, when I was doing the focusing, noticed it seemed to be a bit faster. It might be an illusion. I'm easily pleased. So we're a full moon. Well, we're 92% or 8% off a full moon, and we're having this lovely view of NGC 188, which is also Caldwell 1. It says it's a distance of 4,800 light years away. John Herschel discovered it in 1831. Let's just alter the black level up a bit. And let's stretch it a bit more. See some of the noise now coming out, but that stretches it nicely on 2. So we're using darks. I did the darks today, but the darks were done at a sensor temperature, I think, of about 8 degrees, I suppose, and now it's 6.8, so we're 1.2 degrees off when we did them. To be fair, I can't see any hot pixels or anything there. It seems to be working okay. The flat is old. The flat is a month old at least, since the last time we observed, maybe longer. I think it's longer than that. But where I'm using a Schmidt-Cassegrain telescope, it's all sealed. Everything's sealed, and it doesn't. And when I cleaned it out on one of my previous videos, it doesn't seem to get the dust. So I just carry on using the same flat until it don't work. And currently it appears to work. So let's zoom in a little bit. Yeah, that's nice. So that's a nice little, we're only going to go 2 minutes and 12 in terms of total observation. It's because we're dithering every 3 frames. And we're doing a 30 pixel dither, which is quite a lot. But we've also got the Sigma clipping set up, I think. Hold on, let's just, initial count of 7, down from 10. Normally is. And on enhancements, I think we've got our normal, we've got bilateral, the bilateral filter, and we've also got the unsharp mask on as well. But don't you see 188? Look at Cephas. Reflection Nebula. It might not be the night for nebulae, I don't think. NGC 7160. If I select that, look at the information, what have we got? So, 5 arc minutes. Let's center that a second. That is one thing, it doesn't show a deep sky image. I mean, you can do it with the plus version apparently, but as I said, I wasn't prepared to pay that money, so I was just looking for another object to go. But I do really want to take a peek at M27 again while it's there. I think we could say we've done it, shall we? We can adjust, make it slightly darker, and we can maybe, I don't want to put it up too much. I mean, it's a rich, I say rich, it's a kind of dispersed, but it definitely is a cluster, isn't it? It's a nice object. Let's log it.
Observation NGC 188 created.
And let's head back to M27, so let's target it and slew.
Telescope slewing 66 degrees.
I hope my timeout's okay on this. Oh, M27's quite low, isn't it? Oh no, 39 degrees, that's fine. Oh, we're going to go straight past M57 as well. What's the temperature out there now? Oh, the temperature's 4.3 degrees. Ambient, 6.7 on the sensor. Here we come, M27.
Slewing completed.
Oh, and it's right there in this window. So that's good. Let's sync the planetarium. M27. Let's go for. Wait for the satellite to go through. Let's do an 8-second one, just for fun and giggles. Not sure whether we need a new focus on that. Some of the stars looked slightly puffy. There we go, classic. Let's wait for the next one. Yeah. Oh, actually, let's just do the colour. Bit green, but never mind. Oh dear, that was my tummy. Stretch it out. Oh, of course, we're on a. Let's make it a little bit brighter. Zoom in a bit. So that's 6 frames stacked. So adjust the black level up a bit more. Stretch it a bit more. Meaning that the red needs to either come up or go down. Let's have a look. I think up. What are we at? Oh, we're at 106%. That's the reason we're a bit. There we go, 100%. Awesome difference. Wasn't really, but anyway. So 104 seconds. Let's get some information on it for you. What do we got? Description. Brightest planetary nebula in the night sky. It's also the first planetary we discovered. It's a feast for the eyes. Well, we know this, we've seen this many times. oxygen shell is moving outwards at 15 kilometers a second, while a faster nitrogen shell is expanding at a rate of 30 kilometers per second. Any other data? It's 8 arc minutes. Position in the sky. Doesn't give a distance. No. Apparent magnitude 7.1. With a negative radial velocity, which means it must be coming towards us at 41.8 kilometers per second. And it sets today at 23:59, nearly midnight. Well, exactly midnight. Excellent. I could do a few things there. 2 minutes 24 seconds. Nothing on that one. Oh, there we go. We seem to have an orphaned. I just thought, why don't we see if we can see Orbicular 0571. So if I say VSX, I was trying to find out what the other name for it was. 63394. There it is. And what we'll do is let's use one of our tools.
DSA completed.
Excellent. Let's bring up the DSA, just do a nearby one quickly. Fast, isn't it? Let's paste in our object. There it is. So we're 100%. Let's move in a bit more. See if we can see anything in our no, nothing. It does this. Can we come out a bit? There we go. See if we can move it towards the. It is being a bit slow tonight. It's because this is up, maybe. Ooh. I don't see anything there. Nope, I don't see anything. Which is interesting because it should have reached minimum sometime, in early November, so it's obviously very low. And on tonight with my 8-second exposure, I can't see that star. It was a Myra type variable star we looked at earlier on in the year, but not there now. Not obviously it's still there, but it's not visible. Not tonight anyway. Maybe a longer exposure, but I don't do a longer exposure tonight, not with the moon. So that's 4 minutes and 56, coming up to 5 minutes on the next one. There you go, 5 minutes and 4. Let's log that.
Observation M27 created.
So 92.1% full moon. And we can see with Electronic Assisted Astronomy the beautiful planetary nebula M27. But not Vorpicula B0571. So we could record that, but I'm just going to delete that from our plan for tonight. We can alter this again, make it a bit of a darker background. Some people prefer darker. Maybe I can boost it slightly. And I think I'll log that one as well. So just grab a snapshot.
M27 appended.
Just grab a snapshot of that. While we're here, we might as well go to the Ring Nebula then. Take a look at the Ring Nebula. Let's target it. And slew.
Telescope slewing 18 degrees.
Not very far. Let's sync the planetarium. Oh, I can't sync the planetarium because we're still waiting for the slew to complete.
Slewing completed.
There we are. That'll be pretty good tonight with the precision. Let's move it up a bit. Up a bit more. And across. Across. No real need to do that, but I thought I would. While we're here, let's do a I don't know what I went there for. Let's do a multi-star. So we've gone positive and negative now rather than in and out, so we've changed that. So I'm going to come out 30. But I have backlash compensation, so as you may notice, it's shot out and then shot back in again to get rid of that backlash. Let me reset that. And let's come in. So this is where the box where I'm focusing on these stars here, and as you notice, they're off center. So my Schmidt-Cascone definitely has field curvature, and I've tried different spacings and things like that, but it still has distortion at the edge of the field, and it still definitely has curvature to it. Whether that's part of the focal reducer not being precise, or whether that's how the focal reducer is, I don't know. I know that the Star Zoner one is meant to be far better, but that's a lot of money and we're not going to buy it. But one thing I was doing was that I thought if I focused out here, and it wasn't me, I thought about this, I read it somewhere, if I focus slightly off center, then it will give me a kind of an averaging effect across the field. More of the field would be roughly in focus rather than just the central bit precisely and spreading outwards in this, worse focusing as you go further out. I don't know what's happened here. It's gone all funny. Okay, let's start again. It all went a bit haywire. I don't know if something came over. I wasn't rewatching the field of view. I focused a couple of times tonight and it was perfect, so maybe it doesn't like being watched. So we'll try one more time. That seems better. Something must have occurred while I was wittering onto you. There we go. Yep. Let's do, we'll do 4 seconds because it's quite bright. 100%. Let's get rid of some of that noise. As we stack, that noise will reduce. Central stars, obvious, as always. Game is probably not the best night for doing nebula. This is our image inside Starry Night, location of the telescope, which is wandering slightly. I'm not sure I quite like the way it does the plus and the CPOWI, the name of the ASCOM driver, I suppose, so close. But as they give you the source code for the SDK, as part of the SDK for the plugins, I wonder if I can just rebuild it and change the text. Oh, I want to change what's displayed here. Yeah. If it works out, I'll put a link to the. It is on GitHub. I put but it's not public. But I will put out the software. Then, if anyone wants to make their own plugin, or use this one or adapt it, basically correct the horrible coding, then I might make that public as well. But I think it's fairly niche to have remote control, maybe, I don't know. All I'm saying is that nearly every astronomy application I use, and that could be because I like it, has a scripting language and usually remote access. In fact, SharpCap doesn't, but because SharpCap has quite a powerful scripting language, I'm Python in it, it's really straightforward to create your own remote way of connecting. I'm using a rather weird way. I'm using MQTT through a Mosquito MQTT server because I use Internet of Things sensors around the house, and so it was just easy enough to write it so I can communicate by MQTT. But if you go onto the scripting forum on SharpCap, you'll find that there's a gentleman there who's a person, so I don't know who it is, a person there who's written it using HTTP, which works really well. It's just I'd already written MQTT and I'd already used the file way of using files to communicate, but so I haven't bothered rewriting it using HTTP, but he's doing a kind of remote interface, so that looks quite useful. And as always, Robin's there to support people in this endeavour, and maybe he did ask what people would like, so maybe he'll actually add in an official way of doing remote access to scripts and the object model, maybe, I don't know. But yes, they usually go hand in hand. You have a way of accessing it and a scripting model built in. So the Sky's got JavaScript, Solarium's got JavaScript, and obviously a remote way of accessing both. Though Solarium's also got the remote control plugin that allows you to access a whole object model as well as just running scripts and so on. CDC's got an object model for running scripts, I think, and also for controlling certain things. C2A has the same. SharpCap has whatever you want it to have because you write it yourself, obviously. So, but that's fine. And AstroPlanner has, I think, it's Solo script, which and a way of accessing it remotely. But Starry Night Pro doesn't. Maybe Starry Night Pro 9 if there ever is such a thing. So we're going 2 minutes and 8 seconds. You can now see quite clearly the second star, which we usually see. That wasn't kind of visible before, but now where we're stacking, it's starting to come out. There's a little smudge there, which most probably is a galaxy. So let's just do our super fast. Oh, there we go. It's IC 1296, of course. Yeah, IC 1296. Now this particular, I think I've got in my settings, or not settings, display, here you go. Yeah, this could be the reason it's slow actually. I've got a nearly 1.4 million catalogue inside Deep Sky Annotation. It's the Hyperleader Magnitude 20 catalogue, but it's only designed for my, so I downloaded the Hyperleader database into a Postgre SQL database, and then I just run a query against it. And obviously I created another file from that, which was basically for my latitude. So obviously I didn't want everything I couldn't see, and I also specified a limiting magnitude, in this case up to and including magnitude 20, even though my scope is like 18, 19. But I think it's the difference in visual magnitude compared to photographic magnitude. So I went for 20, and that gave me nearly 1.4 million objects, which, as you see, it does work. But I suspect that's the reason it slows down a bit, because it has to keep on scanning 1.4 million entries, or however Robin does it to create this. I'll put it back on again. Objects nearby, oops, and objects in view. Yeah. Well, I think that was just a quick observation session. I might carry on, but I didn't put any more objects into my planning script tonight. I hadn't done it for so long, and when I started it up, I'd forgotten. Usually my setup is like, you do this, done. And today it was kind of like, oh, no, that doesn't work because I didn't start that, and oh, that didn't work because I'm using the wrong version of my script, and things like that, where things had moved on, but my brain was still a month ago. And so it took a bit of time to get going. When I say a bit of time, not very long, but it took me to remember, you should do it that way. But once you get going, it was good. Starry Night Pro, I mean, it's nice enough. I quite like it. I liked it because of the three-dimensional views of the solar system and things like that, which I found quite interesting. But there again, if you go to JPL Horizons, you can see the orbit of a comet. Maybe not quite so pretty, but it's good, and there are other applications that do it. It has got some interesting objects in it, and then again, it's got objects that are missing, which Stellarium has. Stellarium seems to have a lot more objects in terms of the PGC catalogue and so on. And also, because this is the Pro version, it hasn't got the DSS picture. But also, I'm not sure about the DSS picture, because I do believe Stellarium actually goes at a deeper level than Starry Night, because Starry Night had to fit this onto a DVD, I suppose, or even a CD, I'm not sure, but DVD maybe. I take it as a DVD, surely. Yeah, so 4.7 gigs. So, yeah, if you've got it, then I think it's all right. And if you want to control it, then maybe I'll put out my code so you can laugh at it and adjust it to how you want. But I think that's quite nice. So the moon's over here. It's getting quite. It's getting quite bright. Center, and I think this has got a catalogue as well. Have we got this? So it's the moon. If I keep on going down, will it get better? Oh no, that's about it. Not bad though. I think you can mark up the. And go to the surface as well. Or I can mark it. Markers and outlines. Check all shown. Oh wow, yeah. So it shows me uncheck all. Yeah. All very good. So on that note, thank you very much for joining, and I hope it's clear skies where you are. Have fun.